Welcome to AP Chemistry. We really don't have time to go over what this Chapter 1 notes. This is really just a review for you. I will cover some material pretty quick and then we will move on. In chemistry, it is very important that you recall that we have two types of numbers. We have exact numbers that are obtained by counting, and then we have inexact numbers that are obtained by measurements. And we do a lot of measuring in AP Chem, so this is what we're going to deal with most of the time. Let's recall that your measurement is subject to a little bit of your opinion. The last value in any measurement that you make is your guess. It's estimated. So if you measure a distance and you decide that the distance is 1.25 meters, you think that this is a 5. It could be someone else measures the same thing and thinks it is 1.24 meters. This is the degree of uncertainty in your measurement. It is always the last number that you measure. Please recall that every measurement must include a number, the magnitude, and a unit. We all need to be on the same page, so make sure that you have no naked numbers. They have to come with a unit. All right, you need to be able to convert from one metric unit to another metric unit, and I will leave you to remember how to do that. Here are the symbols for the prefixes for the metric units. The base unit is a meter, a liter, or a gram. So you could have kilograms, you could have millimeters, and you could have microliters. We use nano, a very small number, usually during atomic theory when we're talking about wavelengths of the visible spectrum. We use just two temperature units in this class. We use Celsius, that you are familiar with, and Kelvin, which you should also be familiar with. The reason that we use Kelvin is there are no negative numbers in Kelvin, so it doesn't mess with some of the calculations that we use. A lot of times we will be using pressure, energy, and volume in our gas laws, and you can't have a negative volume, therefore you must always use the Kelvin temperature scale. No Fahrenheit here. Okay, ladies and gentlemen, the folks at College Board, and really any scientific endeavor, want you to correlate your numbers to precision in measurement. So we use something called significant figures. Significant figures should tell the reader how well you measured something. Okay, so first of all, you need to be able to count the number of significant figures in order to use them properly. Okay, here are the rules. All non-zero numbers are always significant. Here are some examples of that. Zeros to the left of the first non-zero number. Here are zeros to the left of the first non-zero number are never significant. They are placeholders only. Numbers between, zeros between non-zeros numbers here and here are always significant. They are place numbers as well, but they are denoting value. Zeros at the end of a number that contains a decimal place anywhere are always significant. This number has no decimal. It has one significant figure. This number has a decimal. It has 4 significant figures. Here's where the precision in your measurement comes in. This would be somebody that is using a scale, the kind that you would have in your bathroom, to weigh themselves. They weigh 100 pounds, plus or minus this one digit. This is someone who masked themselves on a very precise scale. You can be assured their weight or mass is 100. The only thing you're unsure of is the tenth of a pound. There you go. These are leading zeros before a non-zero number. It is not significant, even though there's a decimal there. It only counts for here. Okay, unfortunately, life is tough, and the rules for multiplying, dividing, and adding and subtracting significant figures are not the same. When you are multiplying or dividing numbers, you match the number of significant figures in your answer to the fewest number of significant figures in the calculation. Round your answer to the least number of sig figs. This number has 4. This number has 3. You put it in your calculator, it spits out that. Your answer may only contain 3 sig figs. This is the first significant figure, this is the second, this is the third. Here is the cutoff. This number will influence that number. It is above 5, so you need to round the last significant figure up. Now, when you add and subtract, there's a different rule. If you were to add these numbers together, your answer should match the number of decimal places in the number that has the fewest number of decimal places. Someone did a wonderful job of measuring this value to this many decimals. Then we added it to this sort of imprecise measurement with only 1 decimal. That means that this number has to be sort of imprecise as well. When you added that up, you would cut off the number of decimal places at 1. Scientific notation is great, and we need to use it because nobody can spend time putting big numbers or little numbers into their calculator, so we use a shorthand. Scientific notation has a coefficient, a base 10, and an exponent. This tells you how many times you moved the decimal place from its original number. Here, 567,000 has a decimal place right here. Most time we don't put it there. To put it in scientific notation, we're going to move the decimal between the first and the second non-zero number, and then we are going to tell the reader how many times we had to move that decimal to turn it into scientific notation. If you move the decimal to the left, that is, you make the number smaller, the exponent is a positive number. If you move the decimal right, that means you've made it bigger, the exponent is negative. Here are some rounding rules. Please read them. We're going to use dimensional analysis. Dimensional analysis is our friend and helps us move a problem along using the basic thought process that you write a number and its unit that you start with. In the next step, you put the unit on the bottom that you start with and the unit that you want on the top, and then you multiply and this always is a conversion factor. Remember, a conversion factor are 2 things that are equal to each other. Here is a conversion factor. 1 inch is equal to 2.54 centimeters. 1 dozen is equal to 12 eggs. Anything that's equal can be made into a conversion factor. All right, please read precision and accuracy. Accuracy has to do with correctness of a measurement, while precision has to do with the number of times that you get that number. So if we were to use this target scenario, an accurate dart throw would be one that hit the bullseye right here. A precise throw would be one where you threw it in the same spot every time. So this is neither accurate nor precise. This is precise. You threw it pretty much in the same general vicinity. This one is accurate and precise. Okay. We recall that density is a physical property of a substance, and it's the ratio of mass to volume. It is influenced by temperature because volume is influenced by temperature. We can read the states of matter. And here we have the classification of matter. Matter is subdivided into two general categories, pure substances and mixtures. Pure substances are further subdivided into elements, those things that you see off of the periodic table, and compounds. Compounds are two or more elements that are chemically bonded together. These can only be undone by a chemical change. A mixture can be subdivided into a homogeneous mixture, one that looks the same throughout, or a heterogeneous mixture. Mixtures can be divided by physical means. Okay. Mixtures can be divided by physical means. There's two types. Here are some physical separation techniques that we will be using, especially the chromatography.